My name is Lee Howard. My company is Retevia. We do IPv6 consulting, training, translation, the whole transition consulting. 10 years ago, I came to NANOG and I talked about the total cost of ownership of carrier-grade NAT. And I provided a spreadsheet, something like this, that said you could plug in some numbers and talk about how many things broke when you did carrier-grade NAT because the address sharing was a little complicated. And then you could talk about your costs. And I came up with something like, the whole point was to let you do your own math. And I came up with something like at around between $30 and $40 per user, around $30 to $40 per IPv4 address. You're better off buying addresses than doing carrier-grade NAT. Well, it's a few years later, and the cost of addresses is climbing. I think it's time to revisit this. So I looked at the price of IPv4 addresses. I've got data here from IP Trading and IPv4 auctions, Hilco, they're here. And so I've got both of their data plotted over time. I used sort of the most recent data for the past couple of years. You can see, of course, when you have a few transactions, predictions, trend lines go in strange directions. But it's a really interesting cluster, isn't there, of data you can see if we project, it's just a quadratic extrapolation, that's what it looks like is the best fit. We can see that it looks like we're going to hit about $30 an address, maybe as soon as the end of this year or in a year, next year. And it looks like maybe $40 in 2020, sometime in 2020. That's not that crazy. This is not a very steep curve. I don't want to be in the business of making price predictions. That's a great way to go broke. I don't want to be providing advice that anybody wants to sue me over. So do talk to a broker if you're interested in what the transactions are looking like and what they think the predictions are. But I'm just taking the historical data and extrapolating it forward. So it's not that far away from $40 or $50. We're talking 3 years. That's your normal strategic planning window, right? All right, so now we're at the $30 to $40 I was talking about. We're looking at not that far away from there. Of course, IPv6, right? That's the alternative. So let's look at the growth in IPv6. I've got 4 different data sets here. The blue line is Eric Vinke, among other things that he looks at. He looks at the top 50 websites in the US. Right now, about half of those have IPv6. That's good. And that trend line is increasing. And if the trend continues the way it has been in the past, we could say that 100% of websites 100% of the top 50 websites in the US would have IPv6 in 2024, 5 years. All right, that's kind of cool. The green line is Dan Wing. He measures the top 25,000 global websites. And so all of these have similar kinds of trajectories, but a little bit less percentage of penetration. And there we'd say something like 2026 is when 100% of websites in the world, or 100% of the top 25,000, will have IPv6. Then the other 2 lines, the red and yellow ones, are Google's data and APNX data measuring how many users have IPv6. That's global. And again, we can extrapolate that and say, so sometime in 2026, maybe 2027, at current trends, if those continue, if we don't have an S curve and a long tail tapering off, we might hit 100% IPv6. That's great news. It's about the same. Funny thing, with the price data and this data, quadratic curves. That seems to be the best fit with all of it. But this is a little bit longer than the slope of the IPv6, of the IPv4 address curve. So what happens between 30, 40, 50, et cetera, dollars per address and this price? Well, not good things as far as I'm concerned. There's a problem when some people have to pay for addresses in order to enter a market and others already have them, or others are already holding on to address space, trying to keep competition from being able to compete. So I've been thinking about this and looking at it as there seems to be within that window of people who haven't deployed, which apparently is not most of this room, which is good news, there seems to be a hesitation that if I'm the last mover, then I'm the winner because I've delayed making that expense or that effort longer than anybody else. But if everybody says, I want to wait until my competitor deploys IPv6, and the competitor is saying, I want to wait until my competitor deploys IPv6, then we have something that looks like kind of like a game of chicken, or maybe the prisoner's dilemma, where if I know what your strategy is, then my strategy changes. So I've been thinking about this so the prisoner's dilemma, cops arrest 2 people and say, you're going to jail for however many years. If you rat out the other guy, then you'll go free and that guy will go to jail. But if they rat you out and you don't say anything, you'll go to jail. And if you rat each other out, a different number of years in prison. So And permutations of this, different variations, have different amounts of time in jail for each of those. So I'm looking at this. One of the ways that you solve this is you look at a payoff matrix where you compare the potential strategies of the two players. So player A either rats out or doesn't rat out. Player B rats out or doesn't rat out. In this case, player A, across the top I have content providers promoting IPv6 or not promoting IPv6. And on the side I've got carriers promoting IPv6 or not promoting IPv6. And it looks to me like, okay, if carriers and content providers all promote IPv6, then everybody wins. And it looks to me like, you can see the other permutations. If nobody does anything, then everybody's spending money to keep IPv4 going, eventually. And it doesn't happen at the same time for everybody. But what's really more interesting to me at this point, I said, okay, well, that's obvious. Anybody can see that. But what's interesting is to say, well, how big a difference is that strategy change? If it costs me 10 cents to deploy IPv6, but I only get 5 cents worth of benefit out of it, maybe I don't even want to spend the hour doing it, right? That's not a good strategy. So we would like to be able to assign some numbers to these so we can compare the values of the various strategies. All right, let's see if we can do that. Let's look at the payoff matrix. Let's start with carriers. And I'm talking about both fixed broadband ISPs, cable, DSL, FTTH, whatever, and mobile carriers. So we can start with what does the cost of, how do they make their money? They make their money, there's some combination that subscribers pay them revenue. And that revenue is divided, the average revenue per user per year, ARPU, is divided between whatever it costs to provide the service and the profit on the service. Some years ago, I looked at the operating income and operating expenses for a bunch of ISPs, and I decided 30% was a decent average. So that's what I'm using here. It doesn't really matter, you can do your own numbers. So if you have 30% profit, all right, okay, for example, if you have a tier of service that's $165 a year, then your profit at 30% is $49.50. Now, that's okay, so that's just the way that math works. But if in a couple of years we're talking about you have to buy an IPv4 address at $50 in order to turn up that user, then all of a sudden your costs actually exceed your total, your revenue. So at $50, the first year of service for a customer is negative 50 cents. Well, I don't want to surprise anybody here, that's not profitable. So what do you do about that? Well, oh, by the way, some people are probably saying $165 a year. We don't have tiers that are just $100. That's what we charge per month. That's not a tier we have. Well, if you live in one of these countries, there is a service that is a broadband tier for $165 a year or less. So it is a real thing, and there exists tiers not all of these are developing economies with low broadband, by the way. Okay, so your options are, if you want to be profitable as address prices are climbing, your options are raise prices. On $165 a year, you're going to raise prices by 50 bucks. That's really a huge increase on that tier. That's probably not going to go over well. Now, you could require extended contracts. Say, okay, the first year isn't profitable, but we're going to make the profit over 2 or 3 or 5 years, which may or may not work in your particular market. If you're in a highly dynamic, ephemeral market where people move around a lot, that may not work so well. Address sharing, of course, carrier grade NAT, depends on what might break with that service. You can deploy IPv6, of course. Of course, I'm going to say you can deploy IPv6. That is really only a unique option, a standalone option, if IPv6 is a replacement for IPv4. You can't just deploy IPv6 and say, okay, I'm done, if you still want to provide IPv4 connectivity, if you still need to provide IPv4 connectivity. You can say, you know what, this is too hard, I'm not going to make any money, turn down the customers, sell off the addresses, I'm moving to Hawaii. Or probably most likely is some combination of those above options. And I think the most likely one is to say it's probably some combination of address sharing and IPv6. And here's why. In the US, this is Facebook's chart, in the US, IPv6 is about 55, maybe it's nearly 60% of hits on Facebook come over IPv6. So all right, you can take maybe the lower users are less likely to use, less likely to have problems with carrier grade NAT. They're less likely to do BitTorrent. They're less likely to do high intensity head-to-head gaming, those kinds of things where CGN potentially raises problems. And from my understanding, CGN is not as bad as it used to be. So maybe you could say, I'm going to deploy IPv6 and put some customers behind carrier grade NAT, And then your problems are solved. In fact, if you do 100-to-1 address sharing, you can sell off 99 addresses and make a profit there. Probably, maybe not. Well, what does it cost? Let's talk about the cost of carrier-grade NAT and see how this plays out. So again, this is not the same number, but carrier-grade NAT, you've got to buy some hardware and you've got to buy some addresses. It looks to me, doing a survey of retail prices of NAT vendors, that hardware is reasonable to estimate at $1,000 per gigabit per second. Go talk to your vendors, they're going to give you a completely different number depending on your relationship with that vendor. And this might be, in fact, for a redundant pair because you probably don't want to deploy these alone. So $1,000 for a gigabit per second of capacity, and then some IPv4 addresses for the outside. All right, how many IPv4 addresses do we need to buy? Well, there's a recent thread on NANOG, very helpful, thank you NANOG, that somewhere between 200 and 1,000 users can fit on 1 gigabit per second. I'm going to go a little towards the low end. I'm going to call it 400. And that's because your capacity it's not your full capacity for all customers, and because we're talking to 2 or 3 years in the future. So 400 customers. But I still don't know how many addresses I need. I just know I need enough addresses for 400 customers. So then I go to who can tell me, how do I figure out what a reasonable address sharing ratio is? The mobile guys are pretty much all doing address sharing, right? They all have NAT now. So let's go look at them. So I looked at the number of IPv4 addresses that mobile carriers are announcing. This is per CADA mostly, I think is where I found this data. And then I looked up their public announcements about how many subscribers they have. And then I just did division. This is not going to be exact, right? But it's going to be close enough if we're just trying to pick a realistic number to get some idea. And there's this great range of just under 1 address per user to 26 addresses per user, pretty wide range. I'm delighted to find that they're at least in the same order of magnitude. And it turns out they get an average of about 10 users per address. That's what mobile carriers, by and large, are on average doing now. So let's use that for our model, 10 users per address. At $50 an address, so if I've got 400 users, 10 users per address, I need 40 addresses. At $50, 40 addresses times $50 each, that's $2,000. So my cost for carrier grade NAT is $1,000 per gigabit plus $2,000 per gigabit. That's $3,000. I should have included, and I didn't talk about it before, you're also going to have to update your provisioning systems and your OSS and your monitoring, all those tools. And I ballpark that at $2 per user. It looks to me, when I've talked to ISPs who are doing these things, that the very large ISPs do have more systems that have to be updated. It's more complicated. Smaller ISPs maybe have systems that are off the shelf and require fewer custom updates. So it ballparks at $2 per user. And then I'm going to use that same number for power, cooling, monitoring, staffing, space, all of the annual operating costs. There you go, cost per CGN. This doesn't include any breakage. The stuff that I was really on about a while back, that's not included here. So you probably want to throw in a little bit of discount for the number of tech support calls you get, people complaining about not having native v4 or whatever. So now I can say the cost of CGN is, for 400 users, $3,800, which works out to $9.50 per user. All right, that's, okay, it's probably a little more than I expected, but that's not too crazy. And this gives me enough that I can now go back and populate that payoff matrix. So if carriers deploy IPv6 and content promotes IPv6, so carriers don't need to do all this address sharing, then carriers win. They get to avoid that $9.50 and $2 a year, whatever the annual OpEx is. If carriers promote IPv6, hoping that they don't have to do CGN, but content providers don't do IPv6, then they do have to spend this money. Well, that's how carriers lose, is they spend the money to deploy IPv6, and it doesn't pay off for them. Now, this is definitely proportionate, right? If 50% of websites have IPv6, then your cost is less because you have to do this for fewer users or less traffic. So that definitely helps. And of course, if carriers do nothing, they have to do one of the other strategies. Maybe, I'm saying they buy addresses, maybe they give up and they move to Hawaii. All right, good. Now let's talk about the payoff matrix for content providers. Well, so content providers have definitely noticed that IPv4 has run out. They've gone and bought addresses. Out of 134 million addresses transferred in the address market, you can see that the content providers are buying the bulk of them. Amazon and Amazon.com are about 40% of the total transfers. Thank you to Brendan Kerbis and Milton Mueller for this data. Really fascinating. There are a couple of ISPs on here. Charter and Frontier have both bought some addresses, but really we're looking at the cloud providers, the content providers. That's the people who are growing so fast they're worried about still having addresses. Okay, so what does matter to content providers? It turns out that speed actually significantly impacts content providers' profitability. And I found this, I looked over and over trying to figure out what would matter to them, and I found a quote from Amazon that every 100 milliseconds of latency costs them 1% in sales. I'm quoting them, I didn't make that up. Akamai said 100 millisecond delay in page load time can hurt conversion rates by 7%. Google did an experiment where they added more results to the front page of search results and found that that more results actually delayed the page return by half a second, which caused a 20% drop rate. Now, for an ad site like Google, they're supported by ads, right? That's how they make their revenue. 20% drop rate means they don't get to serve those ads. They don't show you the ads, you don't click on the ads, they don't make the money. So that's correlated directly to revenue. Why are you bringing up speed, Lee? We're talking about IPv6. What does that have to do with, or the overall market? What does one thing have to do with the other? Well, it's fascinating that there is, over the years, this pretty overwhelming body of data that shows that IPv6 is actually faster than IPv4. And it's significantly faster. This is LinkedIn looked at AT&T, Sprint, T-Mobile, and Verizon, and this is the percentage improvement of V6 over V4. 15%, 25%, 17, 18%, and 2 or 3%. But that's all of the mobile carriers in the US, right? And it's the same thing for other countries too. And we find this over and over and over. So there's a summary slide here, but I want to stop on this one and point out, I don't know why I have Africa listed twice, that IPv6 is faster pretty much everywhere you go too. The only place it's not is China. You can make up your own reasons for why it isn't faster in China. And I looked at this yesterday, or actually I looked at it this morning, and it's more like right now, Europe I think is 20 milliseconds, Americas and Africa are more like 30 milliseconds. V6 is 20 to 30 milliseconds faster than V4. That's kind of incredible, and I really want to make the point that the number of people who have looked at the speed comparison and have done head-to-head comparison or research has been not just multiple different organizations and people, it's multiple different methods of doing so, and it's been consistent over the last 6 years. That seems to me it's pretty incredible, and I think that's enough that I can say that V6 actually is faster than V4. I don't know why, I have some theories, maybe I'll submit a lightning talk, but I can say there's enough measurement, all the data that we have says that this is the case, so I'm going to assume that the data is true, the data are true, and that this is the case. Okay, so I had to point out, some people might ask, well, gee, okay, so it's 20 milliseconds or 30 milliseconds faster, but those quotes that you had were talking about 100 milliseconds. Is 20 milliseconds proportionately as much benefit as 100 milliseconds? Fortunately, LinkedIn tells us that yes, every half-second page load time increment results in a very linear decrease in the page views. And that red line it's not a perfect line, but it's pretty darn linear until you get up to about 5.5 seconds. So that says to me that yes, every increment is worth as much as any other increment. So 20 milliseconds is worth about 1/5 of 100 milliseconds. It's a linear improvement. Let's go back to let me talk about what happens there. Because there's a correlation, obviously, between latency and web speed. So and not everybody here is a network engineer, so I just want to point out that when we talk about the internet being a series of tubes or pipes, if bandwidth is how wide the pipe is, then latency is how long it is. And so it doesn't matter if you've got a certain amount of data, it's going to take a certain amount of time for that data to get to you, no matter how big the pipe is, just because you have to traverse that length. Now, in the modern web, most browsers open 6 simultaneous connections when they're downloading websites. They don't do more because people have found in their studies that more than that actually begins to tax the browser or the CPU of the client. I'm going to skip over quick HTTPS pipelining because I only have a few minutes. So a typical website might have 50 or 100 or 150 different things that you have to download in order to display the whole page. So browser opens up 6 connections, downloads them at whatever speed. As each one completes, it opens up the next connection, and so on and so on. And of course, that's including, there's still the TCP handshake time and all that set up too. Now, what happens is if you are able to decrease that time by 20 milliseconds, then it's like moving the web server 20 milliseconds closer to the client, which improves the speed. And it's not just a 20 millisecond improvement, because that first connection finishes 20 milliseconds sooner and the next one starts 20 milliseconds sooner. That seventh connection then starts 20 milliseconds sooner. And it finishes in 80 milliseconds, and the one after that. So it becomes a cumulative benefit the more web objects you have to download on your website. There is math for this. So page load time is approximately the number of objects you have to download divided by how many simultaneous connections you have times the latency. So for example, if you have 150 things to get in your website and you've got 6 simultaneous connections, 20 milliseconds is worth, do the math, it's worth 500 milliseconds. 20 milliseconds equals a half a second in page load time. That's important because some of the quotes that I have are talking about page load time and some are talking about latency. So I just wanted to show that there's a correlation there. These are directly correlated to each other. So now let's look back at these quotes. So if Amazon says that 100 milliseconds of latency costs 1% in sales, and Akamai says 100 milliseconds is 7%, and Google says a half a second is 20%, well then we can say, according to the math, right, then 20 milliseconds equals an increase of 0.2% in sales for Amazon. I'm using their quotes and math. I didn't make this up. I'm just using what exists on the web, what they've said. Akamai said 20 milliseconds well, it said 100 milliseconds is 7%, therefore divide by 5, you get 1.4. And Google said a half a second of page load time is worth 20%. I can do the math. A half second is worth 20%. They said that. Wow. You know, and it's not just these guys. Other people have said similar things. BBC, Pinterest, lots of people have said that this is true. This is sort of generally accepted in the web commerce world that performance equals money. I really like this, and it's true over time. I really like this bottom one though, Mobify. I don't know who they are, but they said that 100 milliseconds of page load time, by increasing their speed by just 100 milliseconds, that they were able to see an additional 1.11% in conversions. And then they did the math and said that 1.11% was worth $380,000 to us. That's 100 milliseconds of page load time, by the way, not latency. So that made me go, oh, you know, if you can do the math and say that percent increase is worth that many dollars, then I can do the same thing for these companies because they make their revenue numbers public. So 20 milliseconds would increase Amazon sales by 0.2%, which is worth $400 million. That's what they said their sales are. That's how much they said speed matters to them. Akamai, 38 million. Google, a half a second increase is worth over $1 billion to Google. I'll come back to that too. Now we can populate this payoff matrix, and we can say, with actual numbers, right? We can say that if content promotes IPv6 and carriers promote IPv6, Amazon makes an additional $400 million a year, Google makes an additional $1 billion a year. If content providers don't promote IPv6, then, okay, maybe they're not losing money, but they're missing out on that additional revenue, right? And then, you know, Amazon, maybe they're finished buying. Eventually, they're going to need more addresses. Who knows what it looks like in 5 or 10 years? So maybe Amazon and Google keep buying addresses, or maybe they don't. But there's potential increased costs to them and definitely missed revenue. Remember, the whole point of this, though, was talking about it as if it were a prisoner's dilemma, which I'm told by an economist it technically isn't because the best payoff isn't necessarily ratting each other out. But I wanted to use this as a controlling metaphor. So the point is, if you know what the other guy's interests are, then you know you can develop your own strategy based on their strategy. So let's talk about strategy. If I'm an executive at Amazon and I understand that IPv6 is worth $400 million to me, then why am I selling any device that doesn't support IPv6? I'm costing myself money by selling these things. If I'm an executive at Amazon, I'm calling up my team right now and I'm saying, we need to tell all of our vendors that we will not carry any home gateways that don't support IPv6 effective June 6, 2020. Because I want to see the additional revenue that I get from that. I would start with home gateway manufacturers, but I'd include all consumer electronics because it all matters. We still need IPv4 as long as all this stuff doesn't have IPv6. And it's probably a no-brainer, but I'd also be telling the team to enable IPv6 on Amazon.com. Good, yeah, that's not the rest of us don't think that's that's a problematic statement. Would this actually matter? I wanted to show, yeah, I think it would. Amazon's about 5% of the US retail market. And I showed earlier, half of the US has IPv6. Which means if Amazon only sold v6 capable home gateways, then 5% of the home gateways in the US would be IPv6 capable. And then between those, probably half would go to homes that already have v6 and half would go to homes that don't have IPv6. Okay, so just by selling only v6 capable home gateways, we'd increase the deployment of IPv6 inside the US by 2.5% per year. That's cumulative. Does that matter? As a matter of fact, North American sales were $141 billion last year. Increasing that by 0.2%, by 2.5% of users, times the 0.2% in sales, yes, just that one thing, just in the US, or just North America, would make $70 million worth of difference, compounding annually. If I'm an executive, I'm looking at that, and that's my risk tolerance. I'm willing to take a couple of risks if it means I can reach $70 million. How much risk? Well, that's your own internal math. By the way, dual stacking Amazon.com, if the world has 28% of the world has IPv6, almost 29% this morning. 28% of the world has IPv6. Amazon dual stacks their site and gets a 0.2% increase in revenue. That means that their global sales increase by $116 million the first year. That's not selling home gateways. That's just dual stacking Amazon.com based on their statements about the benefit of speed. IPv6 is faster. Amazon makes 0.2% more money when their site's faster. Therefore, they make $116 million by dual stacking Amazon.com. I don't understand why anybody wouldn't do that. Google, similar kinds of things. Now, Google has already been very supportive of IPv6. Great job on almost everything they're already doing. If I were an executive at Google saying I'm missing out on a potential $1 billion a year in revenue, I'm saying, well, maybe I'd like to influence some other people to deploy IPv6 also. What can I do to do that? One of the things I could do is say, we know that search results are one of the factors in search results is page load time. That Google actually uses real user data to look at page load time, and pages that would appear in similar results, in similar searches, one of the factors is how fast they load. Google also knows that v6 is faster than v4. They've got their own measurements. I haven't talked to anybody at Google. I assume that they see the same thing as everybody else. If IPv6 is faster and search page rank is higher based on faster page load, then put out a blog post saying so. I think every marketing department in the world is calling their webmaster right now saying, wait, we can improve our search rankings just by dual stacking? I don't know what dual stacking is, but do it. Let's get the marketing people involved. And we haven't even talked about the additional revenues. Another sort of non-controversial statement is, sure, it'd be nice to see IPv6 in every Google Cloud platform, right? Everything they do there. Right now, it's just barely a little bit of IPv6 support. Similar to Amazon, they could promote IPv6 certified devices in their search results. And why does Android not require v6 on everything? Not just the apps, but the other end they're connecting to. It's time to really push this stuff if you want to see these kinds of additional revenue numbers. Alibaba, you're in kind of the same industry, right? I don't want to pretend that this is just Amazon and Google. I looked at some other e-commerce sites, and I looked at their online sales for last year. I multiplied it times, assuming a 1%, because that was sort of the mix of e-commerce results. Multiplied by 1%, assuming that their sales are evenly divided around the world, and said, okay, 28% of the world has IPv6. So by dual stacking your site, you would get an additional 1% of that 28% in sales. Walmart.com dual stacks, they get $47 million in additional revenue. Now that's assuming that their sales are evenly distributed around the world. Since in the US, IPv6 is available to half or 56% of users, it's more like double that. And all these other sites, Macy's, Staples, Home Depot, Best Buy, Dell, eBay. No, Best Buy and Dell, really? Not dual stacked? Come on, guys. You want to make more money? You need to dual stack your sites. Now, sites that make revenue based on serving ads, their model's a little bit different. And again, based on the previous quotes, I'm going to go with 7% increase in sales because you have to serve the ads, people have to view the ads in order for the advertised buyers to pay the websites. So Twitter, $3 billion in revenue last year. They'd make $60 million if they dual stacked. I would really like to see dual stack on Twitter. I'd also like to see it on Reddit. It's a site that I use a lot also. And $2 million. Okay, Reddit is known for having a very small engineering team, being very efficient. Dual stacking, they're hosted by one of the CDNs that also supports IPv6. So there shouldn't be that far for them to go to dual stack. And then of course, all these other sites. Again, these numbers will be double, roughly double, if their sales are predominantly in the US. Now, many people in this room don't work for any of these companies, so I wanted to give you a tool to do your own math. So you can go to this site, you can go to tools.retevia.net, and you can see that it doesn't look quite the same as this, but I've got a JavaScript page that you can plug in how much you think the 20% or 30 milliseconds, whatever it is, would benefit you in sales, what your total online sales are, and the distribution. I hope to come back later and add your own balance of numbers, how much V6 is deployed in each of those regions, but I wanted to be able to reflect that. And so if you've got a $10 million site and 20 milliseconds is worth 1% in sales, you make $46,000. $46,000 is not bad for going on the Akamai portal and checking the IPv6 checkbox. I don't want to leave carriers out in terms of what matters to them. Carriers, you could fund, so if we need Amazon to sell just V6 capable electronics, operators, you could do the testing for them. Put a little skin in there. You could say, you know what, to avoid $9.50 per new user, we could spend 50 cents or $1 in order to test home gateways and other consumer electronics. And I don't care which certification test we do. We can pick any of them. I'd like to include MAP-T, MAP-B, and 464 XLAT because if you're going to do CGN, you might as well do one of the IPv6, IPv4 translation mechanisms so that you can do all V6 locally. And then we can help Amazon, or the carriers can help Amazon and the other e-commerce sites promote IPv6. The other thing that we really ought to be seeing from ISPs is dual stacking our business customers. A lot of those business customers are very small companies that look just like residential users. Just respond to DHCP. Just activate IPv6 for them. For your static customers, assign them a /48 and do a static route. For your BGP customers, assign them a /48 and configure BGP on your side. Keep the session open. It's just hellos. It's not a big deal. And of course, obviously, send email to the customers saying you've done that. Communicate with your customers. Now, when I've talked about this in the past, a lot of people have said, oh, geez, that's going to drive customer calls. That's going to be so expensive. Well, if you're going to go IPv6 anyway, you're going to get those calls anyway. Wouldn't you rather do it in a controlled project where you can control how fast that's rolled out and when you're going to get those calls? You can train your tech support people to know how to respond to those calls, and they're not diluted over 3 or 5 years, so they forget how they're supposed to respond, right? So I didn't want to leave out the carriers. Provided a spreadsheet for you guys also. Same website, tools.retevia.net, carrier-value. Plug in your subscriber counts, your average growth rate per year, how many users you add, and then your current IPv6 deployment level. So if you already have 60% of your users have V6, that's what goes there. How much avoiding carrier right now is worth to you? That's go talk to your vendors, figure out your own compression ratio, what your address prices are, both in CapEx and OpEx, and then how much you think it would help for Amazon and Google and whoever else to support IPv6. That's that middle 5%. And then it'll tell you over the years how much difference that makes to you. It's really interesting, isn't it? If we're talking about just a 5% difference by content chipping in and promoting IPv6, for a million user subscriber, that's $234,000 just in the first year of saved cost, of avoided CGN. And it's really amazing how fast that accumulates because you're also avoiding your annual OpEx, that $2 a year in operating expense, you're avoiding that too. So that's pretty, that's pretty fantastic. Mobile carriers have been really nice. You can help us test, find out what apps don't support IPv6, report those, let's get support for those. And I've heard that there are still some handset makers who sell handsets that aren't V6 capable. And I've heard this especially in developing economies. Now, maybe you're not buying IPv6 incapable handsets, but if your vendor sells incapable handsets to somebody else, Give them a hard time, lean on them, because those developing economies are really struggling now because they can't get addresses and they can't get v6. So help us out, help out the rest of the world so that you can see this additional benefit in avoiding CGN. And I don't understand why a greenfield network like 5G would even have IPv4 on it. But it's not my field. All right, so you kind of see where I've gone with this. What I'm trying to do is I'm trying to set this up so that ISPs and mobile carriers can do some equipment testing, which will help the e-commerce sites, and it will help the e-commerce sites only sell IPv6 capable gear, which helps the ISPs and the mobile carriers turn up IPv6 users, which helps the e-commerce sites make more money. It's this incredible virtuous cycle we have up here at the top. And it's not just the e-commerce sites, but it's also the ad revenue sites that are making more money. That those additional users also help turn up v6 in the cloud, right? That motivates the cloud providers to also support IPv6 on all of their products. And with their help, then the e-commerce sites and all the other websites, it's easier for them to support IPv6 when the cloud providers that they're writing support IPv6. So that's what I wanted to tell you. I appreciate this. I've been talking about the NANOG themes of cooperation, working together as an industry, really a prominent part of what I'm trying to get at in this presentation. But also what I'm really hoping is if we can work together to promote IPv6 for each other's benefit, then we can stop being prisoners of IPv4. Thank you very much. I believe we have time for questions or comments. And there should be some, because I'm talking crazy stuff here, guys. Oh, good. Somebody from one of the companies I mentioned. Louis is going to say, yes, we're committing to do all of these things. No, go ahead, Louis.
Louis Lee, Google Fiber. Thank you very much. This is a great talk. We're DualStack Day 1, so I'm happy to see promotion for everything else. What I wanted to find out is if any of the companies you talked to talked about v6 on the back end, because a lot of that was v6 to the user. And
yep.
If that also improved their serving of the web pages.
Yeah, I've been talking to a lot of enterprises, especially about their cloud hosting. And a lot of them are starting to say, gee, there are cool things that we could do with IPv6 in our data centers that we can't do in the cloud because all we're getting from our cloud providers is the outside of a virtual interface, as we're getting one address on a load balancer. That doesn't really do it for the cool internal stuff. One of the best new uses for v6 that I've seen, I saw a great presentation on IPv6 for containers, where instead of doing multiple layers of NAT, if you're trying to connect from one container on a machine to another container someplace else in the data center, instead of doing NAT as you go through, you could just use IPv6. You can do cool numbering with IPv6, but you can't do that if you don't have IPv6. Personally, I'm also using, for some of my systems, you'll see tools.retevia is hosted on AWS. And the reason is that I can provide IPv6 to all my services internally and externally on AWS. They're doing a really solid job. Not perfect, not 100%, but 85 or 90% of AWS is v6 capable. And it means that my management services are also, feel a little bit better locked down with v6.
Awesome, thank you.
You gotta say something to the lunatic. This is madness. Do people think that we could actually help each other in deploying IPv6? Would this work? Nobody wants to say anything. It's Monday morning, Lee. We had a long weekend. The hackathon kept us up all night. All right, well, I'm around this week. I would love to talk more. And, I can't wait for this one.
Hi, Lee. Peter Timish with Adrex.
Hi, Peter.
I love your price of $50 a number.
I bet you do.
That madness from everything that he posted was math off the page, we call it. We haven't seen any of this, and trust me, we've watched pretty closely. It's one math layer on another math layer. You extrapolate so far off the page that in the end you're posting whatever that link was to say this is how much it'll mean in actual revenue. It's not madness, it's not relevant math. It doesn't mean a thing to a person in this room. That's not why people acquire addresses. It's because it's not interoperable. So while there is, I would bet that 90% of the people who've acquired space through our marketplace, they already deploy IPv6. They need it because it's an and, not an or. So I don't know what you're smoking, but man, I wish we were.
So I wish you were too.
But it's not relevant. This whole thing was a series of whatevers. No, guys, it's because it's not interoperable. Go back to.
But no, and I said that, right? I said that IPv4, that as long as you need IPv4, you're required for interoperability. Absolutely. I'm all about stability on the internet. That's why I keep talking about this.
But no, you're telling people to stop providing service to their customers. Deny on Google an app that is paying with V4. The network is still what people need to get their jobs done. So please, I appreciate your vigor and your august way you want to say things. And if you yell it really loud, you hope people will believe it. None of it was based on reality. It really was absolutely noise in a teacup.
So Peter, I would be delighted to take your price numbers over time, and like all I did was extrapolate a curve. Is that realistic predictions? It's an extrapolation. It's just what it is.
But that's
you can do the same thing.
Manages the people's buying requirements. It's because way back in the day, and you were probably around in 1996, we all raised our hands and voted under RFC 1752 that this was going to be how we're going to go because we were told it was interoperable, and it wasn't. So why don't we back out and say, why are we still propping up a lie?
I will point out.
Question.
So I do feel like I need to push back and say, you have a conflict of interest here. You are motivated to sell addresses because that's your business.
No, I'm motivated to keep the internet growing. There's a business model there. You have a model that you're pushing too. Look, how many people come up here and push models? I'm just saying that no one would come to our store if it wasn't needed. Trust me, there is a real room of smart people here, which in a way you kind of insulted them by saying they're stupid not doing it. They already are. They're really smart, and they're making their decisions based on their actual business needs. No one would visit us. It's not because we're nice people, it's because they need it.
Well, from what John said this morning, most of the people in this room have deployed IPv6. I don't think I'm calling anybody here stupid. And if I've insulted your intelligence, I apologize for that. I was trying to show, yes, a potential model for how to think about this and to consider ways to think about whether there are financial reasons that maybe you haven't considered before. I am not telling people not to use IPv4.
Shaming Alibaba on a stream. What do you get with that? You don't. So
Alibaba's announced an IPv6 strategy.
Everyone here knows we have a conflict of interest. That's because we're transparent about it. But the issue is, then when you're buying, you know you're doing because your business requires it. I can't sell air. It doesn't exist in that vacuum of stupidity. They're doing things for their business. So please, I love the price point. And if you want to pay $50 a number, give me a call. But that's not real either. And that's where you stopped and jumped way off the page in your comparison data. And that's all I'm asking is everyone back out the math and start to see that it's literally a house of cards. And I don't know who here really looked at that math, but go dig into it, because that's where I'm starting with.
That's why I provided the tools, is so you can dig into it. Like, a lot of these are, I'm using numbers that are, here's a basis for using these numbers, but make up your own numbers, absolutely. And as you and I both know, we can talk for a long time on this subject.
Thank you, Lee.
Yes.
One last one, if I may. Anton Capella, Edge Micro. Thanks, Lee. Could I have you seek backwards to slide 16? I think that was
16.
the one where you laid out some basic numbers on kind of the scale and the magnitude. And I want to ask if you can talk a bit more about this, because I'm curious if you can say maybe more specifically what kind of ISP segment, yeah, there we go. What kind of ISP segment are we thinking of when we think of the numbers or look at the numbers you put here? Like, can you narrow that down at all?
So when I looked at the hardware for CGN, I'll be honest, I looked at Google Shopping,
Sure.
And I looked at and I said, what's the price for various different CGN appliances that I know of? And so they're showing me retail prices.
Sure.
So maybe your price is 200 instead of 1,000. I don't know.
Well, I don't want to masquerade an opinion as a question, but I'm just going to say we might be off by 2 orders of magnitude or greater in this assumption.
Yeah, it's possible. Interestingly, when I did this 10 years ago, I was looking back to my old slides, the price for hardware that I quoted was $15,000.
Sure.
So maybe it's, you think maybe it's $100 or $10,
Well, I
$50?
mean, just a case in point. I mean, I don't use this stuff and I don't advocate it, so don't confuse that. This next thing I'm going to say with it. But for $10 or $15, Microtik's making little dinky MIPS and ARM chips push a gigabit through a Linux kernel, and it's mostly fast-pathed and blah 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 efficient. You know, log lookup tries and all that cool stuff. So you know, 1 million sessions and a half gig of RAM is doable. And I'm not doing it, but there are WISPs out there and Cellcos aplenty putting 100,000. 200,000 flows through a $10 device or a VM somewhere, and you'll leave this really patches, as you know, the entire thing together. I'm not advocating for it, but what I'm curious about is, is that price point as high as we think it is, and is that maybe why no one's racing to do this more rapidly?
And that is a perfectly fair, reasonable, great point even. I do think that the numbers are different for mobile carriers than fixed broadband ISPs. And I don't know exactly, because I don't know exactly how the traffic works. Mobile sites tend to be smaller, so that they maybe as many objects, but less bandwidth, or they're optimized differently.
Well, they want us to put React into the browser now.
Right, yeah.
So, yeah.
So does that work out? That's kind of, by the way, I'm hoping, I haven't put it up yet, I do want to put up a CGN calculator like this so that you can plug in your own hardware costs and so on.
The one invited thing I'd love to see you work on or add to something like this would be a regression question, or call it a stress test. What happens if the price falls out on all the stuff we think is expensive?
Oh, interesting.
100x or 200x, something like that.
Yeah, that would be fun.
Thanks, Lee.
Thank you. All right.